Hello, today we're going to start section 1.9, Patterns, Equations, and Graphs. So the first thing I want to go over is a couple definitions. An ordered pair identifies the location of a point on a graph with numbers. So whenever you're looking at an XY coordinate plane, an ordered pair defines the location of a point on that graph. For example, if this is the XY grid, we can identify the location of this ordered pair. These numbers are called coordinates. This is a coordinate point, and it's written in the form of x, y. So that's important. Write that down if you're not sure of what an ordered pair is. And also notice, x comes first, then y. Just like the alphabet, x comes before y. So, yesterday you did the video on Introduction to Equations. Now we're going to start with working with equations. So a solution to an equation is any ordered pair that makes the equation true. For example, the ordered pair 9, 6 is a solution to the equation. Why? Well, remember that first coordinate is your x, and the second coordinate is your y. What we do is we plug them in for the x and y in the equation. So since 9 is my x-coordinate, it's going to be 9 plus, and since 6 is my y-coordinate, I'm going to plug that in for the y here, and I get 6 equals 15. Now, if an ordered pair is a solution to the equation, once you plug them in for your x and y, it should make both sides of the equation equal to each other, which will make it true. Since 9 plus 6 equals 15, I get 15 equals 15. Therefore, it is a solution. If I tried the point 3, 5, is that a solution? Well, if we plugged it in, I get 3 plus 5 equals 15. 3 plus 5 is 8 equals 15. But since 8 does not equal 15, the answer is no. This is not a solution. Wrong. Okay, so it's only a solution once you plug in the x and y coordinate points, and it makes the equation true. 15 equals 15. So try this one on your own. Determine whether negative 3, 2 is a solution of y equals 2x plus 8. So negative 3 is my x, 2 is my y. And I plug it in, and I get 2 equals 2 times negative 3 plus 8. 2 times negative 3 is negative 6 plus 8. Carry everything down. So is 2 equal to negative 6 plus 8? Negative 6 plus 8 equals 2. So yes, it is. So therefore, yes, it is a solution. Try this one. Determine whether 5, 10 is a solution of y equals 3x minus 4. So remember, 5 is my x-coordinate, 10 is my y-coordinate. So I plug it in for my x and y over here. So y equals 10, so it's 10 equals 3 times 5 minus 4. Bring down the 10 equals 3 times 5 is 15 minus 4. 15 minus 4 is 11. So it says 10 equals 11. Since that is not true, they are not equal, the answer is no, this is not a solution. Okay, it's only a solution when the left side equals the right side in the end. Next, we're going to look at using a table, an equation, and a graph to solve a problem. So this is directly taken from page 62 in your book, if you want to follow along that way. So it says both Carrie and her sister Kim were born on October 25th. That's a nice coincidence. But Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So one thing I know is that Kim was born 2 years before Carrie. What I need to know is show this in different ways to represent the relationship. So I'm going to use a table, an equation, and a graph. So the best thing to do when you have a problem like this is to start out by making a table and listing values. So since I know Kim was born 2 years before Carrie, all I have to do is just add 2 to Carrie's age to get Kim's age. So since Carrie is 1, Kim is 1 plus 2 is 3. When Carrie was 2, Kim was 4. When Carrie was 3, Kim was 5. When Carrie was 4, Kim was 6, and so on. If you notice, every single time it's just adding 2. So therefore, we can write an equation. I'm going to let x equals Carrie's age and y equals Kim's age. From the table, you can see that y is always 2 greater than x, because Carrie is going to be x, Kim is going to be y. If it helps, label it x and y next to both their ages. So since we know that Kim is always 2 years older than Carrie, y is always going to be 2 greater than x. So you're just going to be adding 2 to x. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. All we're doing is we're taking Carrie's age, plugging it in for x, and solving for y. Finally, if we look at a graph, we have Carrie's age down here and Kim's age. So when Carrie was 0, when she was born, Kim was already 2. When Carrie was 1, Kim was 3. When Carrie was 2, Kim was 4. They plotted these points. They plotted them as x, y coordinate points. X, y. Carrie's age is my x, Kim is my y. So whenever Carrie's age was given, you can always find out Kim's age because it's plus 2. So you graph each ordered pair from the table up here, and then connect the points with a line. Try this problem. You have 4 more, let's go 3. You have 3 more left socks than right socks in your drawer. How can you represent the relationship between the number of left and right socks in 3 different ways? So I want you to use a table, an equation, and a graph. Okay, so there are 3 more left socks than right socks in your drawers. How can you represent the relationship between the number of left and right socks in 3 different ways? So let's start with a table. So I have 3 more left socks than right socks. So I know that if I have 0 right socks, I have 3 more than that. So I have 3 left socks. If I have 1 right sock, I'm going to have 4 left socks. If I have 2 right socks, 3 more than 2 is 5. 3, 6, 4, 7, 5, 8. Hopefully you can see the pattern that is going on here. Every single time I'm adding 3. So if I represent x equals the number of right socks, and my y equals the number of left socks, I can write the equation as y equals x plus 3. So I'm adding 3 socks to the number of right socks I have to get my total amount of left socks. Finally, if I plot these points, I have a point at 0, 3, So remember, this is your x-axis, this is your y-axis, so it's 0 on the x-axis, 3 on the y-axis, one on the x-axis, 4 on the y-axis, 0.25, 3, 6, 4, 7, 5, 8. And then if I want to graph the line, take a ruler, I want you to line it up and draw a line right through those points. And that is your answer. Now, the last thing I want you to be aware of, and I made the mistake here, is that I extended this into the negative x-axis. I cannot have negative number of socks. So my graph is going to start right at the 0 on the y-axis and go to the right, because I cannot have negative numbers of socks. Alright, finally, last part is inductive reasoning. So the process of reaching a conclusion based on an observed pattern is inductive reasoning. So I have here the table shown. This is also in your book. This is on page 63. The table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in the figure with 8 blue tiles? So look, if I have 1 blue tile, I have 9 total. 2 blue tiles, I have 18 total. 3 blue tiles, I have 27 tiles. It continues. 4 blue, 36 total. 5 blue, 45 total. So there's 2 ways I can figure this out. I can draw a graph. It might take more time, but if it's easier for you to visualize, go right ahead and do so. So first things first, you want to graph the points. Here's 1, 9. Notice how these are going by intervals of 9, 9, 18, 27, 36, 45, 54, 63, 72. And these are going by ones. 1, 2, 3, 4, 5, 6. So 1, 9, 2, 18, 3, 27, and they continue the pattern. Next, we need to figure out the number of total tiles in the figure with the blue 8 tiles. So I go all the way to 8, right here. Look, I stop at 8, and then I find out what my y coordinate is going to be, and it's 72. So therefore, the answer is when x is 8, the number of blue tiles I have is 8, and there's 72 total. Another way you could have identified that is with an equation. So you notice that multiplying it by 9 every single time. So therefore, you could do it y equals 9x, where y is the total number of tiles and x is the number of blue tiles. Plug it in, 9 times 8, it's 72, so you know that the total number of tiles is 72. So this table here shows the relationship between the number of chairs and the total number of legs that the chairs have. Extend the pattern. What is the total number of legs on 10 chairs? So I notice that x represents the number of chairs. When I have 1 chair, I have y equaling the number of legs, 4 legs. 2 chairs is 8 legs. 3 chairs is 12 legs. 4 chairs, 16 legs. 5 chairs, 20 legs. How am I going from 1 to 4, 2 to 8, 3 to 12, 4 to 16, 5 to 20? It seems like every single time it's 1 times a number to get the number of legs, and that number is 4. So you know y equals 4 times the number of chairs, and that gives me the number of legs. Now my question is asking me what is the total number of legs on 10 chairs, so all I have to do is plug it in. Y equals 4 times 10, and I get y equals 40. So there will be 40 legs when I have 10 chairs. Don't forget to finish the Kia quiz, and I hope you have a wonderful day. If you have any questions, please feel free to email me and ask me.